Okay, you guys, so let's go ahead and solve some oblique triangle situations. Here, we don't know what the angle A is, right? We actually know what side A is, but we don't know side B, and we don't know side C. So those are the things that we basically have to figure out for this situation. For the information's given, one of the things that's easy is side A, right? Because we know that the sum of the angles has to equal 180. So the angle A plus 82 plus 24 has to equal 180. So that means that A plus, I think that's going to give us 106, is equal to 180. So if we subtract 106 from both sides, we find that the angle A, right, if we do that subtraction, I believe will be 74 degrees. All right, so we now have at least all the angles involved. So how do I find side B and side C? That's where we invoke our law of sines, right? Because what we now know, right, is that the sine of A all over side A is the sine of B all over B. And if we kind of cross multiply here, if you would, right, we get that B is the sine of A and A times the sine of B. And if we divide both sides by the sine of A, we have what we need. So B is whatever A is times the sine of B all over the sine of A. And now let's just basically plug information, right? What do we know about A? It's 11. What do we know about the angle B? Well, that's the sine of 24. And what do we know about the angle A? Well, we now know that that's the sine of 74. All right, so if we do our math there, let me go ahead and break out my calculator, right? We get that B, let's see here. Hopefully you guys can see that okay. Let me turn my light on. Oh, the glares of this is always, and then in my office is obviously the sun's coming in. So there we go. All right, so putting that in my calculator, right, our B, it looks like it's, let me put this in parentheses, 11, and I've got the sine of 24, close parentheses, and we're dividing that by the sine of 74. All right, and I think, press enter, we get that B, rounding off to some decimals there, it's usually 4, is 4.6544, right? And I don't know if that's meters or feet or whatever. So B, so we know that this is 74 degrees, and we just found B to be 4.6544, right, for this particular situation using our using some technology, since 24 and 74 aren't nice. What about the side C? Well, again, we invoke our inverse sine, or excuse me, our law of sines. So we know that the sine of A all over side A is basically the sine of C all over side C. I went ahead and solved it without the values, but if you want to plug them in, this is telling us the sine of 74 over 11 is the sine of 82 all over C. And so quick cross multiplication, we get C times the sine of 74 as 11 times the sine of 82. Divide both sides by the sine of 74, and we basically have it, right? So our C is estimated. It's really pretty much the same thing, except I'm going to come back. Let me go ahead and re-enter that. That 24 needs to be changed to 82, right? And I think that's all, right? 11 sine of 82 divided by the sine of 74, yeah. And so we get C is 11.33. It looks like 19. So 11.3319 is that side. And so to kind of make sure that we have it right, obviously we have to just check our math. But another way to check that is that idea that a fact about triangles is that the largest angle should have the largest side. In this case, it's 11.33 11.3319. The smallest angle should have the smallest side, right? And then our intermediate angle, the 74 sits between 24 and 82, should have a side that's is intermediate. So 11 is smaller than 11.3319, and it's bigger than 4.6544. So that kind of tells me we're in the right ballpark. I'm going to trust my math. So A is 74 degrees, side B is 4.6544, and side C is 11.3319. And that is how we use some basic knowledge, right, about angles combined with our law of sines to basically figure out all our sides and all our angles. All right, so obviously some more problems coming soon. That's just our first one. But let me go ahead and cut away to a new video with a new situation. See you guys in a moment.